Oh, hi. Thanks for tuning in to another episode of how to get started with your FPGA device. So if you followed along from the first one, you know that so far we've got a tiny FPGA. It's the B2 model I've got. Still waiting for the newer one to come in. But that's a great little FPGA device to get started with. I've already installed all the Project iStorm tool chain, so that's all working. And we left it with a flashing red light last time, just proving that the Blinky Hello World sketch works. What we're going to do today, we're going to look into that in a little bit more detail, see if we can do something a bit more exciting than that. But let's have a look at what we've got first of all. So here's the tiny FPGA B2. I've got it connected up to the computer via the USB cable. I've got pin 13. I brought that down to the LED that's down here. That connects back via a 330 ohm resistor to the negative rail that just connects back into the ground. So fairly straightforward circuit. So all we're going to do is work on pin 13. Going to start blinking it first of all, and then see if we can do something a little bit more exciting than that. So let's take a look at what we've got in the FPGA tools from Tiny FPGA. There is a template for the iStorm project, and in there is this file here. You'll see there's quite a few lines, of which most of them are all commented out. So in order just to tidy it up a little bit, I'm actually going to remove those first of all, just so that we can get it all on the screen without scrolling. You can see what's going on a little bit better. So let's take those out and take that out as well. So what we've got is a Verilog module. In this module, it's fairly straightforward. We've got two pins set up as outputs. Those are pins 1 and 2, which are the USB pins. And then a bit further down, those pins are both assigned a binary value of 0. So that's just turning off the USB. We aren't going to do anything with that today because I don't know what I'm doing with the USB side of things, but that doesn't matter. We can ignore that for now. What we also have, we have a 16 megahertz clock input on pin 3. So there's an internal clock within the tiny FPGA, so that's going to be oscillating at 16 megahertz. And then we've got pin 13, which is the one we've got connected to the LED. So that's set up as a output pin. What we've got specified is a 24-bit register. So this goes from bit 0 up to bit 23. So it's a 24-bit register, which is called counter. Now the always bit of code, the always code, as it suggests, always runs. But this runs every time that there's a positive edge on the clock. So as the clock rises, it will execute everything that's within this bit of code here. So the first thing it's going to do is to increase the counter by 1. So that 24-bit counter is going to go up once at a rate of 16 megahertz. Now, being a 24-bit counter, so the bit 0 of that is going to be oscillating at 16 megahertz. Bit 1 is going to be operating at 8 megahertz. Bit 2 is operating at 4 megahertz, and 2 megahertz, 1 megahertz, etc. All the way down to bit 23, which, when you work out the maths on that, that's going to come out at around about 1 hertz or once a second. So that's the basic code there. Now I've got all the Project iStorm toolchain all installed. Within the template there's a make file, so if we make that will synthesize and compile all of that. Takes a moment or two, and I can then I can program that into the FPGA. So it's erasing it, rewriting it with a bit stream. And success, we've got a flashing red light. So if that's the goal of what you want to do, if that's your biggest aim in life is have a flashing LED, there you go, you've got yourself an FPGA and you've done it. I suspect we could do something a little bit more exciting than just flashing LED. So let's take a look at this code and see what we can add in there to make it a bit more interesting. Now the first thing you notice is we've got a red LED. That's not too exciting. What about if you wanted some colours? So let's start by adding ourselves in a register. Okay, we'll make this a 24-bit register, so it goes up to bit 23, starting at 0, and we call that colour. And yes, colour is spelt correctly. It should have a U in it. We are going to assign the colour of red, and the colour of red is going to be equal to a 24-bit hexadecimal value of FF0000. Now, any of you that have done any HTML programming will recognise that as the same format that HTML uses for its colours there. So you've got FF0000 is red fully on, green and blue off. So let's also assign a colour green, and that again is going to be a 24-bit hex value of 00FF00. Mustn't forget the semicolons, otherwise that won't work. So we've got our two colours there. What we need to do now is to assign that colour, assign one of those colours to our colour variable. So assign colour. Now this is going to, we're still going to use the clock to change it once a second. So we've got counter bit 23. So that's the one that's oscillating at once a second, and we can have either red or green. So we've got that, and then when we get down to pin 13, we assign pin 13 to be colour. So there's the code there. So let's save that. Right, so let's give that a go. Let's give it make, and that all compiles there. Right, that's the bit stream all ready to write. So reset the FPGA to get it back into programming mode, and let's program away. Right, okay, so we've got the alternating colours there, so that's worked out quite nice. What about if you want something a bit more exciting than just two colours? Well, let's add in another colour here. So assign yellow, which again is going to be a 24-bit hexadecimal value. The value of yellow is FFFF00. And then with this one, again we're still going to use the 24th bit of the counter, except this time we're going to set it to be red, then yellow, then green. Okay, make sure that compiles okay. So let's go through, synthesizing, writing the appropriate bits and bobs. Right, okay, and let's upload that. Let's raising it, writing the bit stream. And there we go, success. We have the colours go through exactly as we expected. Red, then yellow, then green, back to red, and so on. Excellent. Right. So that's nice. We can do different colours. What else can we do with this? Well, let's try something else. Let's get rid of the colours and let's have a register. We'll have a 2-bit register. 2-bit register. So that's going to be going from 0 to 1. So it's a 2-bit register which we count up to 4. So we'll call that size. We can take out the colour there. So what we're going to do this time, we're going to assign the size. The size is going to be the counter, and it's going to be bit 23 and 22. So we're taking the 2 highest bits of the counter, apply those to the 2 bits of the size, and sending those down to pin 13. So we've got. So what we're doing here, we're taking just the biggest 2 bits of the of that 16 megahertz counter. Those 2 bits are going to become the size, and when size is sent to pin 13, you'll see what happens as that goes. So, right, so we save that. Reset the tiny FPGA. Let's make. And program it. There we go. So we've learned a couple of things today. We learned how to set different colours, we've learned how to set different sizes, and tune in for the next episode where we're going to use an LDR and a microphone, and we're going to make a very simple bullshit detector. Thank you for watching.